Hi, everyone. Thanks for joining us. I'm Rebekah Tweed. I'm the executive director at All Tech is Human. We're a nonprofit based in New York, and we bring together a global community of over 50,000 people. We've built the world's largest multi-stakeholder, multidisciplinary network in responsible technology. And we are strengthening this ecosystem through multi-stakeholder convenings and community building, multidisciplinary education and resource development, and through our extensive responsible tech career development efforts. So you can check out what we're up to, find out how to get involved with us at alltechishuman.org. You can join our Slack community. We have about 11,000 members across 105 countries. You can subscribe to our All Tech is Human newsletter, as well as our new Responsible Tech Careers newsletter. So, okay, thank you so much for joining us today. I am very excited for this conversation. This is part of our live stream series. We have these every other Thursday at 1 p.m. Eastern. We're on LinkedIn and YouTube. So if you're watching this on LinkedIn right now, please drop us a comment. Tell us where you're tuning in from, and we'll be saving a little bit of time for audience questions at the end. So go ahead and drop those into the comments section at any point, and we'll choose a couple of those. So this discussion today is part of our series This Month in Responsible AI. It's also part of our Responsible Tech Authors series. So I am thrilled to have today with us Dr. Arvind Narayanan.
Hello. Hi, Rebekah. Thank you for having me.
Hi, great to have you today. Arvind Narayanan is a professor of computer science at Princeton University and the director of the Center for Information Technology Policy. He's a co-author of the book AI Snake Oil and a newsletter of the same name. So thank you for being here today, Arvind.
I really look forward to chatting.
So today I want to talk about both your book and your newsletter. I want to focus on your most recent essay, Is AI Progress Slowing Down? And that digs into whether or not model scaling is dead, whether or not inference scaling might be the next frontier, and ultimately why we should stop deferring to tech insiders when we're evaluating those kinds of questions. So let's start there. You published the essay a little over a month ago, December 18th, with your colleagues, co-author Sayesh Kapoor and Benedict Strobel. But this question has been bubbling up for a few months about model scaling laws and whether we're approaching or maybe have met the limits. Why instead of GPT-5 equivalent models, all of these new releases like OpenAI's O1 and DeepSeek's R1 are utilizing reasoning models to improve the model outputs. And I came across your essay and I thought it was a really important and nuanced reflection on the discourse that had been going on. So I wanted to talk to you about this for the All Tech is Human community. And this is a great opportunity to also encourage everyone to read your incredible new book, AI Snake Oil, which, as you say, gives a foundational knowledge, while the AI Snake Oil newsletter covers new developments in the field. So thank you for agreeing to join me today to explain more about where things appear to stand with scaling laws, and then also to help us unblur those lines between AI hype and reality. So I want to start with a quick overview of what model scaling laws are for a broad audience with a varied baseline knowledge, and then what elements affect those model scaling laws.
For sure. So model scaling has been the main way in which progress in AI, specifically generative AI, has been happening over the past 5+ years. So scaling refers to the observation that when you make these models bigger in terms of the number of artificial neurons or components or what have you, and train them using bigger data sets for longer, they become more capable at a very wide range of tasks, all of the kinds of things that we're used to seeing chatbots do, ranging from language translation to writing computer code and so on and so forth. So when GPT 3.5 and then GPT-4 came out, which is around 2 years ago at this point, the rhetoric that we were hearing was that model scaling would keep continuing. There would be a GPT-5 and GPT-6, and that's how AI progress would happen. And of course, that's not quite what has happened, and that's what the essay is really looking at.
Great. Yeah, thank you. And in that essay, you start by talking about how that declaring the death of model scaling is premature. And I would love to have you explain a bit about why you think that. Why is it too soon to say that model scaling has reached its limit?
Yeah, it's weird for us to be in this position, me and my co-authors, because 6 months ago we were one of the few who were pointing out that there is too much hype about model scaling. So it was pretty clear soon after GPT-4 came out and others tried to produce equivalently capable models, and many different labs succeeded. There was enough information from all of these AI developers to know that they were essentially training on all of the easily available data on the internet, right? And so to make models bigger and to make them more capable requires bigger data sets. The data is a big limiting factor. Where are they going to get new data from? There are ways to get new data, but it was not going to be straightforward. And that's why we said, hey, model scaling is not going to necessarily continue indefinitely. We might already be close to the end of model scaling. However, we kept hearing from AI company CEOs that that was not the case, that everything was going as planned, no need for anybody to worry. And then, remarkably suddenly, about 2 months ago, around the time of the NeurIPS conference in November, the narrative flipped that model scaling was over, and a new thing that we'll talk about called inference scaling was going to take over. But our point is that we shouldn't necessarily defer to what industry insiders are saying. It is very understandable that there hasn't been a next bigger generation model after GPT-4, given both the technical difficulties and the questionable business proposition of having a much bigger model that's going to be much more costly to operate. However, it could be that these are both just temporary roadblocks, and companies will find new ways of training bigger models. For instance, they could train on all of the videos on YouTube in addition to all of the text on the internet. That would certainly be more data than current generation models are being trained on. They could find new ways to monetize them. And so I wouldn't give up on model scaling, while also acknowledging that right now, progress in AI capabilities is happening mostly through a different avenue called inference scaling.
And I think it's very interesting, the point you make that we should actually stop deferring to industry insiders on this question. And if you could talk a little more about that, I think that would be great, about how this whole topic did bubble up because of these statements and kind of an about face from major AI developers. So just wondering, yeah, why should we stop deferring, and who instead should we be listening to?
Anytime an AI CEO makes some pontification about the future, it might just be a tweet. There are so many news articles kind of regurgitating that as if it were fact. And, like, why? So, of course, it's true that there are very smart people working in industry and they have access to a lot of information about the models they are building and have not yet released. So I acknowledge that. They might know certain things that the rest of us don't necessarily know because of the proprietary information they have. But I think there are equally smart experts outside industry as there are on the inside. And the advantage of that proprietary information is not that much. As we've seen over and over, it takes only a few months to replicate proprietary models in the open source ecosystem of AI. And so when you're talking about making predictions that are a few years out, an advantage of, let's say, 2 months is irrelevant. And so I don't think they're that much more informed than the rest of us. But most importantly, they have incentives to say whatever they need to say to allow them to raise, the next $500 billion. And we've seen that pretty consistently. As just one example, Ilya Sutskever, who was the chief scientist at OpenAI before he left a few months ago, was one of the biggest proponents of model scaling. And he has said in the past that making these models bigger and bigger is going to lead to artificial general intelligence or superintelligence. And that was a very convenient position for OpenAI to take when they needed to raise money for building bigger and bigger models. But now he's left and he's started up a competitor called Safe Superintelligence, which presumably doesn't have access to the same order of magnitude of capital. And so it's very convenient for him to now have completely changed his tune to say, oh, model scaling is dead, we don't need to build bigger models anymore. It really what really matters is all the cool ideas you bring to the table on the next clever way to make these models smarter. And so that's what he now seems to be saying. And in general, you can almost always draw a through line between these CEOs' predictions about the future and things that they need for their company to benefit from that future.
Exactly. So now turning to inference scaling, which you've mentioned, can you touch on that briefly, what that is and why you think we will see and are already seeing some rapid capability increases, at least in the short term?
Definitely. So inference scaling is the idea of getting the most out of a model after it has already been trained. And so let's say we have a model, any of the models that people are familiar with. It was noticed pretty early on that if you ask it to think before giving a response, it'll produce a lot of thinking tokens, if you will, and that improved the quality of answers on certain types of questions where, the kinds of questions where people might benefit from thinking before giving an answer. So it might not really benefit in, let's say, a language translation task, which really depends on how well you know the two languages. But there could be a really big benefit if you're asking it to solve a riddle, for instance, or various other more economically useful tasks, such as writing computer code. But now we have these so-called reasoning models that have been trained to do a better job of doing that thinking before producing an answer. And so that's one of the ways in which inference scaling could work. Another way in which inference scaling could work is by using these so-called AI agents. And so you might have one language model that's orchestrating various different other language models, asking them to do various things, and then combining the answer. So these are all ways in which you can take the existing model capabilities that we have, and by spending more computational effort when the user asks a question or gives a particular task, try to produce a better answer. So that's the general idea.
Great. Okay. And I do want to get to agents in a little bit, but first I wanted to talk a little about product development, because you talk about that in the essay. You make the case that the bottlenecks for AI's impact, the social and economic impacts, are the pace of product development and the rate of adoption, not necessarily the capabilities of those underlying models. So I would love to have you talk a little about why you think that is. And also, do you think that most people might not have a sense of the true capabilities of those underlying models because product development is lagging?
That's exactly right. And this is one area where I will mostly agree with the hype that's coming from AI companies, which is that, we all saw ChatGPT 2 years ago, and now you can go to chatgpt.com and it still mostly looks kind of the same as it did 2 years ago. And it mostly does still the same kind of things. And so people have seem to have a sense that nothing much has happened and kind of equates AI with chatbots. That's actually not the case, right? On tasks other than just chatting, there has been a tremendous amount of progress. Writing code is one of them. I regularly am able to create simple apps with just a simple, prompt of a few sentences. And I do this a lot when I'm spending time with my kids. You can create apps on the spot to, for me to, for instance, help my kids learn something about fractions or phonics or whatever it is. And, it doesn't always work, but when it does, it's a really magical experience. And people can figure this out if they spend more time exploring these models and various capabilities and so forth. But I understand that for most people, it might not feel worth the time investment to go ahead and do that. And so unless those capabilities are integrated into the existing software that we use, right? And so unless it's in Microsoft Word or Adobe Photoshop for someone who's a graphic designer, we might not necessarily go and explore these capabilities and learn more about them. So I do think there's a gap between how much capabilities have already advanced and the extent to which most people are familiar with them. And one reason for that is that, as you alluded to, AI companies haven't invested a lot of time into product development. They've made these models better, but how to use that to improve your own workflows has been kind of largely up to the user. And I think that is gradually starting to change. So one example of this change is when OpenAI previewed the Sora video generation model. It was, I think, almost a year ago at this point. It seemed quite capable, but also there were very clear limitations because very often it would get details wrong because of its poor understanding of physics, if you will, the physics of the world and of motion. However, they seem to have spent a lot of time building a whole video editor around Sora. And that video editor, in many ways, helps overcome the limitations of this model and allow you to actually produce useful videos, even though the underlying model is pretty flawed. So in my view, there needs to be at least a 50-50 allocation of effort among AI engineers between model development and product development. In the past, that has been askew, and I think now we're getting closer to a more balanced approach.
Okay, and now we do have to talk a bit about the news du jour, DeepSeek. We've heard a lot from a lot of different people, but I know our community is really interested in hearing what you have to say about this. What do you think the release of DeepSeek's reasoning model R1 might indicate about scaling laws, and just more generally, what do you think are the implications of the release of this chatbot?
For sure, yeah, and I apologize to all the listeners who are tired of hearing about DeepSeek already. But for what it's worth, I think there is this simplistic narrative going around that DeepSeek built for $5 million would it cost American AI companies, hundreds of millions of dollars to produce, and therefore that has tanked the stock of NVIDIA and so forth. I think it's a very simplistic narrative. First of all, the $5 million cost is for what is considered the final training run. That's before you do all of the experiments that tell you how you should do that final training run to make your model the best that it can be. So when you add up all those costs, when you consider that DeepSeek has 100 to 200 highly talented engineers, which is not that far off from the teams in the AI companies in the US, the costs actually don't look that different. They're not an order of magnitude different, I would say, based on more sophisticated analyses that I've seen. And similarly, while this is clearly a very impressive achievement, and I would say that China or any other country is only a few months behind the US because of how quickly these innovations can diffuse, it's not that they have done something that American companies didn't manage to do. They were building on top of the knowledge that had already come from the experiences of American companies, even if not everything they did was published in research papers. So in that sense, I just want to take the hype down a peg. But with that said, I think what this means for reasoning models and what we can expect in terms of future capabilities is that there is so much low-hanging fruit in this space. So just to give one example, I don't mean to get too technical, but just just as a simple way to illustrate, one of the most powerful ways in which you can make these language models do more than they can do out of the box is to teach them to use tools. Do a web search if they don't know the answer, or write computer code to figure out the answer, various things like that. Now, what hasn't been done yet, but I'm sure a lot of people are working on, they're at least talking about it, is learning to reason to use tools. So using the reasoning capabilities of these models to know, okay, is now a time when I should do a web search? Is now a time when I should write code? Is now a time when I should, ask another model for advice, whatever it is, right? So that's a simple example of low-hanging fruit that I do think can push the capabilities of these models up quite a bit. And I can, give you half a dozen other examples. So for those reasons, and because now we have open source, and so a much bigger community can work on it. By the way, I prefer the term open weight. There's a subtle distinction between open weight and open source. Because we have these open weight models, I do think progress in these kinds of reasoning and inference time capabilities is going to be quite rapid. It's going to be not uniformly distributed across domains. It's going to be better in coding, in science-related tasks, things where there are clear correct and incorrect answers that benefit from reasoning. But nonetheless, even if it's not a uniform progress across all domains, I do think it's an exciting time for AI capabilities.
Yes, and I want to talk about one major flaw that inference scaling has, which you talk about in the essay. You talked about that it does not work well with agentic AI. So could you explain that a little bit? What do you think those limitations, why do you think those limitations exist? And then would love to hear also about the Holistic Agent Leaderboard that you and your colleague recently released. So if you could talk about both of those.
Yeah, definitely. So over the last couple of years, people have built various agentic scaffolds to take model capabilities and then connect them in sophisticated ways to external tools to get them to do useful things. And when you take those existing agentic scaffolds and replace the underlying kind of vanilla model with a reasoning model or inference time scales model, it doesn't seem to work that well. We have a few hypotheses for why that could be. We don't have definitive answers. One reason could be that the style of prompt that you need for the two kinds of models is different. But I do think this is a fairly temporary hiccup that will get solved relatively quickly, and we are going to see these agentic systems effectively make use of reasoning models, especially if those models can reason about how to use tools, when to use tools, and that goes back to what I was saying earlier about expecting rapid capability increases in certain domains. So HAL stands for Holistic Agent Leaderboard. The name is inspired by Stanford's Helm, which is a model leaderboard, both of which try to take a more holistic look. That is, instead of looking at a one-dimensional sense of accuracy or capability on a certain task, look at least accuracy and cost, but also potentially in the future, various different things, like ease of use in some sense, and so on and so forth. And so that's one of the motivations behind HAL. Another philosophy behind HAL is that right now we're in a situation where we have to take AI developers at their word with regard to what the capabilities of a new model are or a new agent are. And when you look at other branches of engineering, that's a very weird thing. It would be as if car manufacturers were the only ones, testing their crash safety or their miles per gallon or something like that, and we had to take them at their word. And there was no Consumer Reports or EPA or any of these other trusted independent third parties who could do various kinds of evaluations. So with HAL, we want to be that body for AI agents who is not an AI developer. It doesn't have skin in the game. We're not evaluating our own agents. But instead, we're both creating benchmarks, but more importantly, aggregating lots of benchmarks that other people have created. And we're executing these agents in a uniform way across these benchmarks so that they can be fairly compared, and providing a one-stop shop so that people can know, okay, as of now, what is the best agent for this kind of task? How well does it perform? How much does it cost? Any other things? What kinds of failure modes does it have? Other questions that you might want to know in practice about where agents stand for your particular domain of interest.
And then beyond agentic AI, developers are moving into, multi-agent systems, embedding things into wearables, embodied physical AI systems in humanoid robots, things of that nature. And you make the point in your piece that there is a clear recognition that models themselves are just a technology, not a product. But we are now quickly moving to productize these technologies with these growing capabilities. And in your book, you do a great job of laying out what the actual harms are of generative AI and different products. So I'm wondering, how do you think about that moving forward as we're moving into more agentic systems? What kind of harms are you looking out for as we move into this new phase?
Definitely. So in one sense, I think the emphasis on productizing these things is positive development from a harms perspective. So one kind of bad thing that has happened in the first couple of years of generative AI as a consumer technology is that when companies just put these models out there and let people do whatever they want with them, I mean, in one sense, that's great. But what it also means is that it's a lot easier for bad actors to figure out how to use these models for their shady purposes, as opposed to everyday people to figure out how to integrate these into their workflows. So in that sense, my hope is that the move to products will mean that more of these uses will be in a positive direction and in a productivity increasing direction, as opposed to various kinds of malicious uses, which are going to continue, but at least hopefully they won't get any easier if we're developing and releasing these products in a responsible way. So that's one thought. The other thought is there are going to be specific categories of products in which some of the harms will have to be thought through really, really carefully. Let me give just two examples. Let's say you have an AI note taker that is integrated into everybody's Teams meetings and Zoom meetings. We've already had cases where these AI agents, if you will, they're kind of agents, do not understand the access controls and privacy boundaries. And there have been stories of how they sent meeting summaries to the wrong people, revealing a lot of confidential information. So that's, it's a kind of harm or failure that's very specific to a particular category of product, as opposed to here are some scary things you can do using these models. So again, in a sense, it's a positive thing that you can specifically enumerate the harms. What are the things that can go wrong with this product, and how can you fix it with this product? Another example of this is the computer use agents that will automatically use a computer on your behalf. They're vulnerable to something called a prompt injection, where they're asked to visit a web page, get some information, and they mistake some text on the web page for a command that they're supposed to execute. And that web page could be controlled by, a threat actor that might ask your agent to do something malicious, like emailing all your documents out to the hacker. So these are all things that can go really, really wrong with specific product categories that are being built right now. So my hope is that companies are going to put responsible AI at the forefront.
So I have one more question for you, and then we'll turn to a couple of audience questions. The last thing I want to know from you is what's next? What are you watching for? And is there any kind of sneak peek for your next AI snake oil essay that you can share today?
Sure. Let me share a couple of thoughts. One, I've been, and my co-author Sayash as well, we've been very influenced by Jeffrey Ding's thesis. He's a political science professor who talks about technology and the power in the context of great power conflict, right? So when we talk about the US versus China arms race, for instance, his thesis is that there is too much focus on innovation. And that's maybe a little misguided, because innovations can very quickly diffuse across countries, which is exactly what we're seeing with DeepSeek and so forth. But the extent to which a country, a society, is going to benefit from a wave of technological innovation depends much less on the pace of innovation and much more on the pace with which the government, and private industry and society in that country can diffuse that innovation across all kinds of private sector and public sector entities. So that gets to the pace of adoption. That gets to how quickly laws can change so that we put the right guardrails, but also enable productive applications and various other things. These are things that usually don't happen at the speed of innovation, right? They happen at the speed of institutions. They happen at the speed of human social change. Those are the things that I'm seeing are the real bottlenecks. And so for that reason, I've called the pace of generative AI adoption glacial compared to how it is often portrayed in some of the hype around generative AI. So one area of interest is, what can we do in terms of governance, training, finding the right guardrails so that people can adopt these more quickly and with more confidence that the harmful side effects can be avoided. So that's one interest. Another interest is I'm really interested in something that you alluded to, different ways in which we might be able to, different kinds of products through which we might be able to take advantage of generative AI. Just to give one quick example, I don't think this is feasible yet because the hardware is not quite there. What if I could have glasses that are looking through my eyes, if you will, and remember where everything is in my home, so that the next time I misplace my keys or my iPad, they'll tell me where it is. So this might seem a little gimmicky, but I just want to point out that there are so many kinds of things that we haven't even necessarily imagined, both in terms of positive applications, how can it make your life better, but also in terms of the surveillance implications, right? What does it mean for a model to be constantly recording video? Is that, are there even responsible ways to do that without risking catastrophic harms? So those are all things that I'm excited to think about.
That would be incredibly useful. Okay, so I'm going to pull up a question now from Lindsay Gross. How do market incentives shape which innovation stories get told and amplified what stories tend to get left out?
Yeah, definitely. One pattern I've noticed is that, I mean, it's going to sound obvious, but I'll give you an example that might be a little less obvious. The obvious observation is that the applications that are sexy are the stories that get told, right? And the ones that are kind of boring are actually where a lot of the value of generative AI is. So I have, for instance, a former student whose company summarizes like C-SPAN meetings that might be 3 hours long and extracts the information that you need out of it if you're a law firm, for instance, right? Who needs to stay on top of what is happening in the policy conversation around a certain topic, something like that, right? It's, not a again, not a very sexy application, but I think super useful. I know someone else who's actually multiple people who are building AI for translating old code bases that might be a million lines long and written in a language like COBOL, for which there are relatively few programmers who are experts, and how to translate that into a more modern language to make it more easily manageable. So these are the kinds of things that I find very exciting, just because of the enormous amounts of time that it can save people, but you hear less often in the media.
All right, we'll do one more here. Actually, Lindsay has another one. She's on it with the questions today. Who's to blame for the errors of an AI agent? How do you see agentic AI redefining human authorship and ownership in terms of copyright? So some big questions.
Yeah, who's to blame? That's a great question, both in terms of the legal aspect and in terms of the moral aspect. So there are three potential parties here. One is the agent developer, one is the user or the deployer, and a third is the agent itself. I don't think AI agents are moral agents. I don't think it makes sense for a piece of software to have liability. And so really the question is, who is to blame? Is it the user or deployer, or is it the agent's developer? I think the answer really depends on the application. I would say the primary responsibility has to lie with the user or deployer. However, I think it also makes sense for there to be regulation on model developers and agent developers in order to ensure that they are transparent enough about the testing they've done on the agents, about what how they can expect the agents to behave in various scenarios, so that the user or deployer has all of the information that they need in order to make informed decisions about how to actually deploy these agents. So I think both parties should have responsibility, but primarily on the user or deployer.
Great, thank you. Okay, so we are out of time for today. So first of all, I just want to say everyone should pick up AI Snake Oil. The book is incredible. I love how you describe generative AI and deep learning, and you give a great comparison with symbolic learning. I think it's a really great overview, especially for people who maybe don't have a technical background. It's very accessible. So if you're looking to understand how the technology works, it's a great overview. I also think that's super important if you're trying to really understand what the harms of these technologies are. Getting a sense of how they work is really crucial. And I also really appreciated the emphasis on what civil society can do and how what we can do moving forward. So just want to put a plug in for the book. Everyone should pick that up at Princeton University Press. So I do want to thank you, Arvind, for joining me today, and thank everyone for tuning in. You can find All Tech is Human every other Thursday at 1 p.m. Eastern on LinkedIn and on YouTube. You can get Arvind's book from Princeton University Press, and also subscribe to the newsletter. Most of our conversation today came from the most recent essay, AI Snake Oil newsletter, which you can find on Substack, and I can't wait for the next essay. And you can keep up with everything that All Tech is Human is doing at alltechishuman.org. So thank you, everybody, for joining us today. Have a great day.
Thank you. This has been such a great conversation.